For our second day here, we're going to take a look at some more solving trig equations, but we're going to add some identities to this. So, identity is statements of equality between two expressions. For example, the tangent equals the sine over the cosine. And you guys know that because in our triangles here, this has been our sine and our cosine. So y over x, sine over cosine. And I believe we proved that earlier as well. So another identity we're going to take a look at are reciprocals. And you guys know this. They are the inverses, or excuse me, the reciprocals of each other. So the sine is 1 over the cosecant is 1 over the sine. So the next one, let's see if I can bring workspace back up. Sorry guys. But the next one we're going to look at is the Pythagorean identities. So let's see here. There we go. Sine squared plus cosine squared equals 1. So when you think about this, once again, that makes sense because this was our cosine and sine. So cos squared, and in the unit circle, cos squared plus sine squared would equal 1. Now remember, you can move these around. For example, if I would have to solve for the cos squared of theta, that would equal 1 minus the sine squared of theta. The sine squared of theta would move over the cosine squared, so it would be 1 minus the cosine squared of theta. And then all the rest of these, they can be derived from what we had above, from this one right here. For example, tan squared of theta plus 1 equals the secant squared. Well, if you start with these, if you divide by the cosine squared, you end up with the tangent squared. Sine over cosine is tangent, so tangent squared. The cosine squared of the cosine squared is 1, and 1 over the cosine is the secant. And this one's the same thing, except you divide by the sine squared. So we're asked to solve some of these. So for example, the secant equals 3 over 2. Find the cosine. Well, secant and cosine are reciprocals, so this would be 2/3. But what do we do if they're not reciprocals? The cosecant is 4/3, so we know that that means our sine is 3/4. Well, if we were to draw this out, sine, opposite over hypotenuse, 3 over 4. Could we figure this out? Well, yes, we could. We could say 4 squared equals 3 squared plus x squared. So 16 equals 9 plus x squared. So 7 equals x squared. So this would have to be the square root of 7. Some of you might also look at this and you label, well, what if we said that this was 3/4 and this was 1? Would we get that same thing? Well, 1 squared, as if it was on the unit circle, 3/4, oops. Let's see, 1 squared equals 3/4 squared plus x squared. So 1 squared equals 9/16 plus x squared. So let's see, then we have 7/16 equals x squared. Square root that, so the square root of 7 over 4 equals x squared. And then that's the same thing here, because in this case, our tangent over here would be 3 over the square root of 7. So here's our tangent, whereas if we solved it like this and had our entire y value for 3/4, our tangent would be opposite over adjacent. So we have 3 over the square root of 7. So either way works. I tend to say, well, unless our hypotenuse is told it's a unit circle value, I tend to write it this way, but it works the other way as well. So we're asked to solve these. So this is like what we did from yesterday. Our sine is 1/2. So our y value is 1/2. So there's two places where that's 1/2. So 30 and 30. And if it doesn't say, we could solve in degrees. So this is 30 degrees, and this is 150 degrees. The cosine equals negative root 3 over 2. Well, cosine is our x value. So we have negative root 3 over 2. We know opposite that is 60. So again, these are 30-degree reference angles. So we have 150 degrees and 210 degrees. So what do we do if we're asked to solve for this? Well, let's see. What can we factor out of both of these? We can factor out a 2x. So 2x times x minus 4 equals 0. Well, this isn't any sort of trig here. How would we solve this? Well, either 2x equals 0 or x minus 4 equals 0. So either x equals 0 or x equals 4. Well, we can do the same type of thing with trig here. We can factor something. Both of these have the cosine of x in it. So factor out the cosine of x. So then we have the sine of x minus 1/2 equals 0. If we distribute it again, we'd have this. So we could solve this. Either the cosine of x equals 0 or the sine of x minus 1/2 equals 0. So we end up with, well, the sine of x equals 1/2. So this first one here, where does our x value equal 0, the cosine? Well, that would be here and here, because this is 0, 1, 0, negative 1. So we would have 90 degrees and 270 degrees. And then where is the sine of x equal to 1/2? Well, that's our y value of our triangle. So 1/2, 1/2. 30-degree reference angle, so we have 30 degrees over here and 150 on this side. So let's see this next one. Let's add 1. So 3 times the tangent squared of x equals 9. Divide by 3. So the tan squared of x equals 3. Take the square root, and when we square root, we have to take the positive or negative. So this is one, again, those tricky ones. Which triangle does our tangent equal the square root of 3? So I always tend to draw out both of them. It's either a 30 or a 60. So root 3 over 2 and 1/2. 1/2 root 3 over 2. Tangent, opposite over adjacent. So it's 1 over root 3, so it's not that one, so it's got to be 60. Root 3 over 2 over 1/2. So that gives us our root 3. So it's all these 60-degree ones, because it can be plus or minus. So we have quite a few of them here. So we have 60 degrees, 120 degrees, 240, and 300. And now let's just say you needed it in radians. Well, this is pi over 3. 2 times 60, so 2 pi over 3. 4 times 60, so 4 pi over 3. And this would be 5 pi over 3. So this last one, we're asked to solve for this. Well, here we can't factor anything, and we have sines and cosines. Well, let's see if we can get it in just with 1. Well, what do we know sine squared? We had that identity. Sine squared of theta plus cosine squared of theta equals 1. So sine squared, we could replace this with 1 minus the cosine squared of theta, because then we only have one trig value there. So cosine, not value, but only one of the SOHCAHTOA, minus the cosine of x plus 1 equals 1 minus the cosine squared of x. Well, you could think of this as a quadratic, and because we have the squared, so let's set it equal to 0, plus the cosine squared of x, and then minus 1. So we have 2 cosine squared of x minus the cosine of x equals 0. Well, we can factor cosine out of these. So the cosine minus 2 cosine of x minus 1 equals 0. So now we have either the cosine of x equals 0 or the 2 cosine of x minus 1 equals 0. And if we add 1 and divide by 2, we have these two statements. So cosine is our x value again. So where is our x value equal to 0? Well, this is 0, 1, 0, negative 1. And this is in radians, so 90 degrees and 270. So this would have to be pi over 2 and 3 pi over 2. And the cosine, and we have positive 1/2. So this is 30, so this means our reference angles are 60. So we have 60 degrees and 300 degrees. So this is pi over 3, and 5 times 60. So we have 5 pi over 3. So we have those 4 answers. So solve for x in degrees. Well, a little bit more complicated, but we can do this. We got to subtract 3, divide by 2. So we have the sine of x equaling negative 1/2. So sine is our y value. So I'm going to make these triangles where our y is negative 1/2. So we know that this is 30-degree reference angles again. So on this side, let's see, that would be 210. And over here it would be 330.